Hi, I wanted to give you a brief overview of weather forecasting today. So in the United States, weather data and forecasts are made by the National Weather Service, which is a division of the National Oceanographic and Atmospheric Administration, which is part of the Department of Commerce. Weather, I think I've mentioned in class before, weather is one of those things that, computers play a huge role in it, but you can't forecast the weather without a human being in the end. To make a forecast, the first thing a meteorologist needs to do is look at the observations of what's going on with the weather right now. After looking at that, they're going to look at forecast models, which are really just mathematical predictions of what the atmosphere is going to do over time. Now, the National Weather Service and Canada and Europe all run different forecast models, and they each have several forecast models. So there's a whole bunch of different weather forecasts that a human being has to look at and predict what the weather's really going to do. So first step, look out the window, both literally and figuratively look out the window. When I was in college, we did a forecasting class, and we were in the people who would present each day, a different group would present, and the people who were doing the presentation would show up for class an hour and a half early to get their presentation together, and they were in a dark computer room with no windows. And I remember one day showing up for the class. We were not presenting, and it was snowing really hard. It was one of those lake effect things where it wasn't expected, and then it was snowing really hard outside. There's probably 2 or 3 inches on the ground already, and we sit down, and the people doing the forecast start talking about how it's sunny and clear outside, and we're like, no, it's snowing, stop, stop, stop. So that can happen. You have to look out the window. The other thing you're going to do is look at the observations that are either made by humans or by an automated surface observation system, which is called ASOS. Now, the only place you'd really have people making observations are at the actual forecasts office. Most observations are taken by computer instruments these days. All of that information then gets transmitted from the ASOS machine to computers somewhere else, and it would be printed as something called a METAR code, or METAR. This is a METAR code, and if you want to pause it right here and read through how to decode it and knock yourself out, it's not easy to figure out, and if you need more help, you can look up on the internet or ask me in class, because I love doing this stuff. If you've ever seen one of these things over on the right along the side of the highway, they're all over the place. Department of Transportation puts them up, but that's an actual ASOS with all of the instruments. The ones you see on the side of the highway don't have everything. That one will measure cloud ceiling, visibility, wind speed, direction, temperature, dew point, everything. Okay, the other thing that meteorologists do at the actual forecast office, so you see the shipbuilding down there that's on the campus of SUNY Albany on Washington Avenue Extension. The National Weather Service is located on the top floor right where it comes to a point. Every 12 hours they launch a balloon. Now, every forecast office around the world launches a balloon at the same time, so it would be 0Z or 12Z, and they record information about the atmosphere up high. And this is what they get from that. This is a vertical graph of temperature and dew point, as well as wind speed and wind direction, and they can get a lot of information from this. I don't want to get too in-depth into it, but some of the simple things you can get from it are where are clouds, and how stable is the atmosphere, how likely are we to have thunderstorms, that kind of thing. You've probably seen one of these before. This is called a meteogram. You had to make one for your project, but again, this shows the last 24 hours in weather in kind of a succinct format. You see temperature, dew point, any current weather, precipitation, visibility, wind speed and direction, cloud cover, cloud height, and pressure. That data also gets published in map form. So this would be for northeastern United States with station models, and I'm sure I've shown you in class the ones for the entire United States, and with fronts and precipitation and highs and lows plotted. Now this is all done by computer, and a dead giveaway is the fact that extending from Wyoming, Colorado, Utah, Arizona, and Southern California, there's 2 cold fronts kind of overlapping each other. No person would do that. That's just the computer and not being very good at what it does. Another tool that meteorologists have is radar, and beginning back in the 90s, meteorologists upgraded radar from plain old radar to Doppler radar. So with Doppler radar, you can locate precipitation, and it might look something like this. This is the Watertown radar, and you can see the green to the east of the radar site, and you can even make out clouds with Doppler radar as well. TV station Doppler radars usually use a slightly different wavelength around here that's better at picking up snow. The National Weather Service uses the same radar nationwide, and it's not quite as good at picking out snow as it is rain. The other thing Doppler radar can do is it can actually see the air. There doesn't have to be water droplets or ice crystals in the air. It can see the air, so they can use it in clear air mode to see the direction of the wind. Now typically it's going to look like this. Again, we're looking at the Watertown radar station. The green represents wind going toward the station, and the orange represents wind moving away from the station. And that would be typical straight line wind. However, if there were a tornado or supercell, you'd be able to see that because you'd see some orange, a little blob of orange in the green or a little blob of green in the orange. And that would tell you that the wind was rotating, which would be a sign that there's a tornado or at least a supercell that could spawn a tornado. Until Doppler radar, there was no such thing as a tornado warning unless a human being saw a tornado and phoned it into the Weather Service. Nowadays, the Weather Service will issue a tornado warning if they see a tornado on radar as well. The next tool meteorologists use is a satellite. Satellites can see cloud tops in two different ways. There's visible and there's infrared. Now, infrared is probably the preferred because what infrared does, it actually measures the temperature of what's below it. So right now we're looking at that, but what it's doing is it's painting the coldest things it sees white, and the warmest things it sees is darker down to black. So cloud tops are higher up in the atmosphere, so they're colder, and the higher the cloud, the colder it is. So thicker clouds tend to look whiter on this, and no clouds look black. Now the advantage of infrared is it can be used 24 hours a day, day and night. Visible satellite will give you a more detailed image, but it doesn't work at night. It only works when there is sun. So this is visible. This is visible during the daytime, but again, can't be used at night. And then there's a third type of satellite they use called water vapor. It's actually seeing the water vapor in the air, and what this is really good at showing is if you see that dark band going through Texas and Oklahoma, wrapping into the center of a low that's over Kansas, that dry air being pulled into a low can tip meteorologists off as to when a storm is going to begin to weaken. So that's one advantage of using water vapor. Now, all of that data that gets collected by the ASOS machines goes into some supercomputers. I believe the National Weather Service supercomputers are located in Maryland, and you know, back in the day, a supercomputer was a big deal. Nowadays, our PCs are much more powerful than supercomputers in the 80s or the 90s, but they still use, you know, the most powerful computers they can put together to make these forecasts, because the more data you can put into it, the more it's going to slow it down, but the better the forecast is going to be. This is one example of a model output. This is a statistical model output, meaning it's not predicting what's going to happen based on the thermodynamics and the fluid dynamics of the atmosphere. It's saying if the atmosphere has been like this in the past, what's happened in the future. So it's really compiling data and looking at what's happened in the past and making predictions based on that. That's different than the typical forecast model that works based on fluid dynamics and thermodynamics of the atmosphere, predicting where stuff is going to go and how heat is going to affect it and that kind of stuff. This is a typical 4-panel output for pretty much surface level upward to about 500 millibars, which is a pressure, but it's also a height in the atmosphere. It's the height at which you would reach 500 millibars. And what we have here is an 18, a 21, a 0Z, and a 3Z forecast. So it's looking at 3-hour increments over the next 3, 6, 9, 12 hours. I can do math. But this is the problem. All of those forecasts aren't right. Some forecasts are better in the summer, or forecast models. Some forecasts are better in the winter. All of them stink in the spring and the fall. Some of them are better when there's, a storm coming from the south. Some are better when there's a storm coming from the west, and some are better when this and that and the other thing. So it takes a human being with a lot of knowledge to kind of pick out which model to go with, and maybe, well, this is a good model, but it trends a little cold, so I'm going to say it's going to be this model, but a little bit warmer. And so it takes a human being to try to piece all of these pieces together and make a forecast. This is the forecast that the Weather Service puts out. This is called a forecast discussion. This is a forecast discussion for Albany, and again, if you want to pause it and read through it, you can. Most of this stuff makes sense. They used to do it in a kind of a shorthand, and some of the older meteorologists will still type it up in a shorthand that makes it kind of difficult to read. But most people, because they're typing on computers now, it's pretty easy to read, but you might not know what everything means, but you probably know what most of the stuff means. When the Weather Channel, or Bob Kovacic, or whoever, whatever TV station gets a hold of it, they take all of that information that doesn't look that good, isn't easy to understand, and they make it pretty and understandable for the regular person. And that's how a weather forecast works. If you have any questions, write them down, let me know. Talk to me in class next time.